Please subscribe, follow and like engineeringall.com.
Welcome to our in-depth exploration of stepper motors. Whether you're an aspiring engineer, a DIY enthusiast, or just curious about technology, understanding stepper motors is essential. These versatile devices play a critical role in a wide range of applications, from 3D printing and CNC machining to camera lenses and robotic arms. Today, we'll demystify the world of stepper motors, breaking down what they are and how they work. Section 1. Understanding stepper motors. Stepper motors are fascinating electromechanical devices designed to convert electrical pulses into precise mechanical motion. Unlike traditional DC or AC motors, stepper motors excel at positioning and controlling their output. This unique ability makes them ideal for applications that require accuracy and repeatability. At their core, stepper motors are characterized by their steps, which are discrete increments of movement. Each step represents a specific angle, known as the step angle. The step angle is determined by the motor's construction and the number of coils and rotor teeth it has. For instance, a typical stepper motor might have a step angle of 1.8 degrees, meaning it moves 1.8 degrees with each step. Section 2. Anatomy of a stepper motor. To understand how stepper motors work, let's dissect their anatomy. A stepper motor consists of two main parts, the rotor and the stator. The rotor is the rotating component, often equipped with a shaft for mechanical connection. The stator, on the other hand, is the stationary part that surrounds the rotor. The stator typically contains coils of wire arranged in specific patterns, which create magnetic fields when energized. These coils play a fundamental role in the motor's operation. Now, let's delve into step motors' key differentiator, unipolar and bipolar configurations. Unipolar stepper motors have two coils per phase, and the magnetic field direction can be changed by reversing the current flow. Bipolar stepper motors have only one coil per phase, and the magnetic field direction is changed by reversing the current itself. The choice between unipolar and bipolar depends on the application's requirements for torque and control complexity. Section 3. How stepper motors work. Stepper motors work based on the principle of steps, as the name suggests. The magic happens when we energize the coils in a precise sequence, creating a rotating magnetic field that interacts with the rotor's teeth. This interaction generates motion. There are two fundamental modes of stepper motor operation: full steps and microstepping. Full steps involve energizing only one coil at a time, resulting in discrete, well-defined movements. Microstepping, on the other hand, divides each full step into smaller increments, achieved by partially energizing coils. This provides smoother and more precise motion control, especially useful in applications requiring high precision. Section 4. Controlling stepper motors. To harness the power of stepper motors, we need control. Various methods can be used to control stepper motors, but one of the most common approaches is using dedicated driver circuits. These circuits provide the necessary current and sequencing to the motor coils. Central to stepper motor control are two signals, pulse and direction. The pulse signal dictates when to take a step, while the direction signal determines the rotation direction. By varying the pulse frequency and direction, you can control the speed and position of the motor. Microcontroller platforms like Arduino and Raspberry Pi have made stepper motor control accessible to hobbyists and professionals alike. With the right code and driver circuitry, you can make stepper motors perform intricate tasks, such as drawing precise patterns or executing complex movements. Section 5. Applications of stepper motors. Stepper motors find a home in countless applications. Their precision and repeatability make them indispensable in industries like manufacturing, robotics, and automation. For instance, 3D printers rely on stepper motors to move the print head with extreme accuracy, layer by layer, creating intricate objects. CNC, computer numerical control. Machines use stepper motors to move cutting tools or other equipment precisely along multiple axes. Cameras use stepper motors to control focus and zoom mechanisms, ensuring sharp and clear images. Even your inkjet printer employs stepper motors to move the printhead across the page, delivering high-quality documents. Section 6. Advantages and limitations. Stepper motors offer a range of advantages. They excel in open-loop control systems, meaning they don't require external feedback devices like encoders to verify their position. This simplicity reduces system cost and complexity. However, stepper motors do have limitations. At high speeds, they can experience missed steps, leading to inaccuracies. Additionally, they may not provide the same torque as other motor types at high speeds. Proper sizing, control, and cooling can mitigate these limitations. Section 7. Tips for working with stepper motors. If you're considering working with stepper motors, here are some practical tips. Choose the right stepper motor for your application based on torque and speed requirements. Use a driver circuit matched to your motor to ensure precise control. Implement current limiting to prevent overheating and protect the motor. Provide adequate cooling for the motor, especially during prolonged use. Section 8. Conclusion. In conclusion, stepper motors are remarkable devices that transform electrical pulses into precise mechanical motion. Their unique step-based operation makes them invaluable in various fields, from manufacturing to consumer electronics. By understanding their anatomy, operation, and control methods, you can harness the power of stepper motors for your projects and applications. Thank you for joining us on this journey through the world of stepper motors. If you found this video informative, please like, share, and subscribe to stay tuned for more engaging content on technology and engineering. Explore our channel for more in-depth tech insights. Subscribe for regular updates. Follow us on social media for behind-the-scenes content. Thank you for watching, and until next time, keep innovating.
Thank you for watching. Please hit the red button to subscribe for more videos.